Welcome back, students, to our Chapter 5 video notes for Chemistry 1510. We're going to pick up where we left off and talk about another example of Dalton's law of partial pressure. So when we run a reaction and we create a gas that we want to collect, gases are difficult to collect. So what we tend to do is use this setup. So let's take a moment to kind of analyze what's going on here. So first of all, we have your Bunsen burner. So your Bunsen burner is going to be your heat source. And then in this case, you have some solid, in this particular example, it's potassium chlorate, in a test tube. And when you heat potassium chlorate, it ends up decomposing. And one of the things that it decomposes into is oxygen gas. So when we look at the heating of potassium chlorate, the oxygen gas is formed and collects in this container, and as we create more oxygen gas, that oxygen gas ends up traveling through this tube system and into this inverted canister of water. The oxygen gas bubbles up through the water and collects in the top of this container. And so essentially we're using water to trap our gas. So the reason that this is a partial pressure question is because not only is there oxygen gas in this container, there's also water vapor. And this is really hard to remember because really there's water vapor all around us all the time. We forget about it until it's winter time and we go, gosh, our nose is so dry or our skin is so dry, right? And that's because you don't have enough water vapor in the air and your skin or your nose dries out. And so that's why you have a humidifier in your house. So this water vapor is always present whenever you have a body of water. There's always water vapor above that water. And the pressure of the water vapor depends upon the temperature outside. So this P of water right here, that is the pressure of the water vapor above the gas. And again, it's temperature dependent. And so let's just throw out some examples. If the temperature is 15 degrees Celsius, then the pressure of the water vapor is going to be 12.79 torr. Whereas if we increase the temperature to 20 degrees Celsius, the pressure of the water vapor is going to be 17.5 torr. And so these things are not things you memorize. These are things that you look up in a table. When we look at questions that are going to be involving collecting gases over water, they're going to call the gas a wet gas, because that means that the gas that you are collecting, the one that you want to keep, is mixed with water vapor. And so a lot of times what the question will do is it will ask you what is, the pressure of the dry gas or something like this. So let's look at a typical partial pressure question where we collected the gas over water. So this one says a sample of nitrogen was collected over water at 15 degrees Celsius and had a total pressure of 745 torr, and it gives you the volume. What's the partial pressure of the nitrogen? All right, so first hint that this is a partial pressure question is it says, what's the partial pressure of the nitrogen? Right, notice how over here it's giving you a total pressure. That means that before you start any calculations, you have to take the pressure of the water vapor and remove it from the total pressure, because the questions are going to ask you about the pressure of the nitrogen, and we need to subtract out the pressure of the water. So again, this information, that's going to be in a table. If we're talking about the exam, it's going to be at a given table at the end of the exam. If you're doing homework or something, it's going to be in a table in your textbook. So we were given that the total pressure was 745 torr. we're searching for the pressure of the nitrogen, and we know the pressure of the water. We knew to use the 12.79 torr because we were given a temperature of 15 degrees Celsius. So when we go through and we do a quick subtraction, we're going to get the pressure of nitrogen to be 732 torr after we take into account significant figures. So then, part B. What volume would the nitrogen occupy at STP? Okay, so first, let's remind ourselves what STP is. Standard temperature and pressure. So 0 degrees Celsius and 1 atmosphere. So this is a question that's a combined gas law question. And the way that I know that is I'm given a starting temperature, I'm given a starting pressure, and I'm given a starting volume. And so then it's asking you what happens at the end. Now, the one tricky part is the starting pressure that you're given, the 745, is not what you're going to plug in to your P1 V1 T1 over P2 V2 T2, because you just took a moment to figure out what the pressure of the nitrogen is, and this question asks you what the volume of the nitrogen would be at STP. So you're going to make sure that you rearrange this equation appropriately using your algebra skills so that you end up solving for V2 and you're going to plug in all those values. So T2 is going to be your temperature at STP. Remember that 0 degrees Celsius is 273, and we can throw in the 0.15 if you want to, Kelvin. And then your pressure is going to be your P1 is your pressure of the nitrogen. So that's your 732 torr. Your V1 is going to be that 310 milliliters. Your P2 is going to be your standard temperature and pressure, which is 1 atmosphere, same as 760 torr. And your T2 is, your T1 is your 273.15 plus the 15 degrees Celsius, so 288. So you'll put all those numbers in, you'll notice that your units cancel, and you end up with a V2 of 283 milliliters. So that's it for collecting gases over water. As always, thank you for your attention. This is Katoni, signing out.